Hello everyone. In this video we're going to be solving an interesting polynomial equation. If you expand this, you're going to get a quartic equation, obviously. For example, we could square 1 minus 5x squared quantity squared. That is going to give us 1 minus 10x squared plus 25x to the fourth power. And then we can multiply that by 5 and subtract the result from 1 and set it equal to x. Let's see what this gives us. 1 minus, if you distribute to negative 5, you're going to get the following. This is going to be 50x squared minus 125x to the fourth power. And then if you put everything on the same side, you get 125x to the fourth minus 50x squared plus x plus 4 is equal to 0. And you end up with a quartic equation, which is not always easy to solve. There's a quartic formula, but I don't think anyone has memorized it. Even the cubic formula is very hard to memorize. So let's use a different approach, and my approach, of course, involves my most favorite method, which is substitution. Great. So what am I going to do? Well, if you notice that there's a pattern here, look at the expression inside the parentheses, 1 minus 5x squared. So if you call that expression, let me rewrite this equation so I can do it here. I'm just going to copy it. And now in this equation, I can just go ahead and call this y. And you may be asking, why? Because if you call that y, you get x equals 1 minus 5y squared and y equals 5 minus 5x squared. Great. We got the same type of equation where the variables are switched. So we can work this as a system. Now, why did we turn our equation into a system of equations? Because sometimes systems are easier to solve than a single equation. Let's go ahead and solve this equation, obviously. We're going to take advantage of symmetry here, or whatever you want to call it. I'm going to subtract x minus y. That's going to give me 1 minus 5y squared minus 1 plus 5x squared. 1 is going to cancel out, leaving us with something nicer. So I can kind of write it like with the 5 outside. This is difference of two squares. So I can kind of factor it as x plus y times x minus y. And all of that is multiplied by 5. Now notice that this equation is a lot easier than the original one, because the original one is a quartic and I have no idea how to solve this. Maybe you can use Wolfram Alpha or a calculator or some other computer algebra system, whatever. Or if there are rational solutions, which we're going to see at the end, you can try that, but I'm going to use substitution, if you don't mind. Now, how am I going to proceed? Well, I have x minus y, x minus y. One of the biggest mistakes that people do is crossing these out. Do not cross them out because you lose roots. So put everything on the same side. Let's go ahead and subtract x minus y from both sides, but notice that there's a 1 in front of it. So let's subtract like this and set it equal to 0. Now I'm going to take out a x minus y here, and then I'm going to have 5x plus 5y minus 1 is equal to 0. Great. From here we get two solutions. One of them says x equals y or y equals x. The other one says 5x plus 5y equals 1. So we're going to be looking at both of these equations, but remember that y is something we invented, right? It wasn't in the original problem. So now we're going to back substitute. Replace y with 1 minus 5x squared. So here, if you replace y with 1 minus 5x squared, you get a quadratic equation. And this can be written as 5x squared plus x minus 1 is equal to 0. From here, by using the quadratic formula, you can get negative b plus minus the square root of b squared minus 4ac. That's going to be plus 4 times 5, which is 20. And all of that is divided by 10 because that's 2a. And from here, the roots are going to be negative 1 plus minus the square root of 21 over 10. As you can see, we did not get rational solutions, unfortunately. That's just one branch. Let's go ahead and take a look at the other branch. 5x plus 5y is equal to 1. And y can be replaced with 1 minus 5x squared. Let's go ahead and do it. So let's go ahead and separate these. 5x plus 5 times y, and y is equal to 1 minus 5x squared. Okay, and this also gives you a quadratic, so it should be easy to solve. 5x plus 5 minus 25x squared equals 1. 25x squared minus 5x minus 4 is equal to 0. Again, this equation has two real solutions because a and c have opposite signs. And from here we get x equals negative b plus minus the square root of b squared, which is 25, minus 4ac, but that's going to be a plus sign. And 16 times 25 is equal to 400. And then we can just divide it by 2 times 25, which is 50. And then we're going to be getting from here x equals 5 plus minus. Now let's take a look at inside the radical. We have 425 inside the radical, and that can be written as 85 times 5, right? Okay. 85 can be written as 17 times 5, so this is 25 times 17, which means you can pull out the 25 as a 5, and you have a 17 inside the radical. And of course, that's being divided by 50. Therefore, the other solution in the simplest form is going to look like, if you divide everything by 5, you're going to get 1 plus minus root 17 divided by 10. And notice that both of the equations are divided by, both of the values are being divided by 10. Now, is there another way to approach this problem? Probably difficult, but we use substitution and we got the solutions. There are no extraneous solutions. This is a quartic equation and it has 4 real solutions. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.